We have the following strategy for solving rational equations by factoring. We eliminate fractions by multiplying both sides by the common denominator. We solve the resulting polynomial equation by factoring. And very important, we check that our answers are not zeros of any of the original denominators. An alternative method would be to move all terms to one side and put all fractions on the common denominator. Since a fraction equals 0 if and only if its denominator equals 0, we will end up with exactly the same equation as given by the strategy above. Let's illustrate this with the examples on page 64. Solve the following rational equations. Question 1. 5 over x minus 1 over 4 is 3 over 2x. The denominators are x, 4, and 2x. So the common denominator, which is the least common multiple of x, 4, and 2x, is 4x. Note that we will have to check our answers to ensure that 4x is not 0. So here's the equation, and we multiply both sides by 4x to eliminate fractions. Next, we distribute. And finally, we simplify. For the first term, we have 4x times 5 over x. X cancels out, we are left with 4 times 5, which is 20. For the second term, we have 4x times 1 over 4. 4 cancels out, and we are left with x times 1, which is x. For the third term, we have 4x times 3 over 2x. X cancels out, and 4 over 2 simplify to 2 over 1, and we find 2 times 3, which is 6. Next, we solve this new equation. We subtract 20 from both sides and get negative x is negative 14. Multiply both sides by negative 1, and we find x is 14. Before we conclude that this is a solution, we must check that 4x is not 0. So 4 times 14 is 56, which is not equal to 0. So now we know for sure that x is equal to 14 is the solution. Question 2. 16 over x plus 2 is 3 plus x over 2. The denominators involved are x plus 2 and 2. So the common denominator, the least common multiple, is 2 times x plus 2. Note that we will have to check our answers to ensure that 2 times x plus 2 is not 0. So here's the equation, and we multiply both sides by 2 times x plus 2 to eliminate fractions. Next, we distribute. And finally, we simplify. For the first term, we have 2 times x plus 2 times 16 over x plus 2. X plus 2 cancels out. We are left with 2 times 16, which is 32. For the second term, we have 2 times x plus 2 times 3. 2 times 3 is 6, so we get 6 times x plus 2. For the third term, we have 2 times x plus 2 times x over 2. 2 cancels out, and we are left with x plus 2 times x. We distribute and find 32 is 6x plus 12 plus x squared plus 2x. We simplify by combining 6x and 2x. We get 32 is x squared plus 8x plus 12. In order to solve this equation, we must have a 0 on one side. So we subtract 32 from both sides and get 0 is x squared plus 8x minus 20. To solve this equation, we use the factoring method. So we are looking for two numbers whose sum is 8 and whose product is negative 20. We see that 10 and negative 2 work. 10 plus negative 2 is 8, and 10 times negative 2 is negative 20. So we can factor immediately as x plus 10 times x minus 2. Now we set each factor equal to 0, x plus 10 is 0, or x minus 2 is 0. We solve these new equations and find x is negative 10, or x is 2. Again, it is very important to check that 2 times x plus 2 is not 0. For negative 10, this becomes 2 times negative 10 plus 2, which is negative 16, which is not 0. That means that x is negative 10 is a solution. Next, we check for x is equal to 2. We check 2 times 2 plus 2, which is 8, is not equal to 0. So x is equal to 2 is a solution as well. Hence, our final answer is x is negative 10, or x is 2. Question 3. X plus 4 over x plus 2 minus 1 is equal to 3 over x squared plus x minus 2. The denominators are x plus 2 and x squared plus x minus 2. To find the common denominator, we need to factor x squared plus x minus 2. We are looking for two numbers whose sum is 1 and whose product is negative 2. We see that 2 and negative 1 work. 2 plus negative 1 is 1, and 2 times negative 1 is negative 2. So we can factor x squared plus x minus 2 as x plus 2 times x minus 1. Thus the denominators are x plus 2 and x plus 2 times x minus 1. Hence the common denominator is x plus 2 times x minus 1. We will have to check our answers to ensure that x plus 2 times x minus 1 is not 0. So here's the equation. We multiply both sides by x plus 2 times x minus 1 to eliminate fractions. We distribute and factor our denominators. And now we simplify. For the first term, we have x plus 2 times x minus 1 times x plus 4 over x plus 2. X plus 2 cancels out, and we are left with x minus 1 times x plus 4. The second term does not need to be simplified. For the third term, we have x plus 2 times x minus 1 times 3 over x plus 2 times x minus 1. X minus 1 cancels out, and x plus 2 cancels out, and we are just left with 3. Now we FOIL. X minus 1 times x plus 4 becomes x squared plus 3x minus 4. X plus 2 times x minus 1 becomes x squared plus x minus 2. Be careful with the parentheses. Now we distribute the minus sign and find x squared plus 3x minus 4 minus x squared minus x plus 2 is 3. We simplify. X squared minus x squared cancels out. 3x minus x becomes 2x, and minus 4 plus 2 is negative 2. So we get 2x minus 2 is 3. We solve this new equation by adding 2 to both sides and dividing both sides by 2. Again, we need to check that x plus 2 times x minus 1 is not 0. So 5 over 2 plus 2 times 5 over 2 minus 1. We put everything on common denominator 2. So we get 5 over 2 plus 4 over 2 times 5 over 2 minus 2 over 2, which is 9 over 2 times 3 over 2, which is 27 over 4. And that is not equal to 0. So now we know that the solution is x is 5 over 2. Question 4. 2 over x squared minus 1 is 1 over x minus 1 plus 1 over x plus 1. Denominators are x squared minus 1, x minus 1, and x plus 1. To find the common denominator, we need to factor x squared minus 1. We use the difference of squares. X squared minus 1 is x squared minus 1 squared, which factors as x plus 1 times x minus 1. So the denominators involved are x plus 1 times x minus 1, x minus 1, and x plus 1. Hence the common denominator is x plus 1 times x minus 1. We will have to check our answers to ensure that x plus 1 times x minus 1 is not 0. So here's the equation. We multiply both sides by x plus 1 times x minus 1 to eliminate fractions. Next, we distribute and factor the denominators. And finally, we simplify. For the first term, x plus 1 times x minus 1 times 2 over x plus 1 times x minus 1, x minus 1 cancels out, and x plus 1 cancels out, and we are left with just 2. For the second term, we have x plus 1 times x minus 1 times 1 over x minus 1. X minus 1 cancels out, and we are left with x plus 1 times 1. For the third term, we have x plus 1 times x minus 1 times 1 over x plus 1. X plus 1 cancels out, and we are left with x minus 1 times 1. We simplify this equation. We find 2 is x plus 1 plus x minus 1. Simplify more, and we find 2 is 2x. We can solve this equation quite easily by dividing both sides by 2. But remember, we have to check that x plus 1 times x minus 1 is not 0. So when we substitute 1 in there, we get 1 plus 1 times 1 minus 1, which is 2 times 0, which is equal to 0. So this means that x is equal to 1 is not a solution. Hence, there are no solutions.